Hi, in this lecture video, I will be discussing the SI prefix multipliers. So first, we'll describe what they are, and then I'll go over the list of SI prefixes that you need to remember for this class. And then we'll go over how to use the SI prefixes, and next, how to convert between the SI prefixes. So let's get started. So first, what are SI prefixes? These are basically essentially terminologies that we use to express the scientific notations. For an example, rather than saying 1.5 times 10 to the third, this is normally the way how we would describe a scientific notation. And we can see that it takes some time. 1.5 times 10 to the third. It takes about 2 to 3 seconds to be able to say this number. So rather than saying that, we can now say the following, 1.5 kilo. So in this case right here, the prefix kilo is being used to describe this exponent right here, times 10 to the third. So that's what SI prefixes are. They're basically names or terminology that correspond to certain exponential notation. And some of the commonly used exponential notation are given SI prefixes. We do not have SI prefixes for every single exponential notation, but only some of the commonly used one. And each of the SI prefixes are then given a name. And this is the name that we will be referring to when we speak about it or when we have to say it. And an abbreviation. And the abbreviation is then used in writing. For an example, the prefix kilo. So when we write it, it will be kilo. And it is abbreviated with the lowercase k. So when we say it, we will call this a kilo. So this is for speaking. And when we have to write it, we'll be writing this with a k. So that is abbreviation. So this is for writing. And below are the different SI prefixes and the exponent that they correspond to that you need to memorize for this class. So let's write this, memorize. So make sure you remember this, because this is something you need to remember in order to use them, and they will not be given to us on quizzes and exam. So these are the different SI prefixes that go all the way from 10 to the negative 18, which is a very, very small value, to 10 to the 18, which is a very big value. So negative 18 is atto, and that is abbreviated with the lowercase a. And 10 to negative 15, this exponent right here, the prefix for that will be femto, and it is abbreviated with the lowercase f. And then pico, nano, micro. So micro is with this u right here, and then milli, centi, deci. So all of these are negative exponents, have negative exponent in them. Now 10 to the 0 is then equal to 1, and then there is no prefix for that. 10 to the first is deca, and that is abbreviated with da, hecto, kilo, mega, giga, tetra, peta, and hexa. Please note how this abbreviation right here are lowercase, versus the rest of them are all lower cases. I'm sorry, these are upper cases. Versus the rest are lower cases. And so please remember this, and also please be able to determine which prefixes is larger. So here in this case right here, we will then see that kilo is bigger than hecto, right? And the reason why it bigger kilo is 10 to the third versus hecto is 10 to the second. So 10 to the third is bigger than 10 to the second. So therefore the prefix kilo is bigger than hecto. Now how many times is kilo bigger than hecto? The answer, by 10 times. So a difference in the exponent equal to 1 equal to 10 times differences. So in this case, kilo is 10 times bigger than hecto. And similarly, let's do another example. Between kilo and mega, which one is bigger? Then answer very clearly, mega would be bigger. So mega is to the 6, and 10 to the 6 is then equal to a million, right? Versus kilo is to the 1,000. So in this case right here, we'll see that mega is actually bigger than kilo. How bigger in mega compared to kilo? The answer, 1,000 times. So if we were to take the exponent here and subtract it, 6 minus 3 equal 10 to the third. And this is how many times that the mega is bigger than the kilo. So we would then need 1,000 kilo to equal to 1 mega. So that kind of how it would work. And now moving over here to the negative exponent, then the further it is to the right side, then the bigger it will be. So in this case right here, deci is actually bigger than centi, and centi is bigger than milli. So please remember that. So the larger the negative value, then the smaller it is. So let's now do a few problems as well. Between milli and micro, which one would be bigger? And the answer would be milli. Milli is 10 to the negative third, which is then 1,000 times bigger than the micro, which is 10 to the negative 6. Okay, so make sure you are familiar with this. And again, please be aware that we're working with negative exponents. The bigger the value, the smaller it would be. Okay, and if we need to know how many times is one prefix bigger than the other, then what we would do as follows: simply take the bigger prefix, the one with the more positive the exponent, and subtracting the small exponent, and that will allow us to figure out how many times is one prefix bigger than the other. For an example, if I were to now do another example with kilo, between kilo and micro, which one is bigger, and how many times is one bigger than the other? Then the answer, kilo, would be bigger, right? Because kilo is 10 to the third. So it's bigger than 10 to the negative 6. Now, how many times is a kilo bigger than the micro? Then the answer would then take the exponent. So in this case right here for kilo, it is to the third. And now subtract the small exponent. In this case right here, micro, and micro is negative 6. So we are subtracting a negative 6. 3 minus negative 6 then equal to 9. So basically 10 to the 9 times larger. Okay, so a kilo is 10 to the 9 times larger than a micro. So that is how we can determine how much is one bigger than the other. And now, let's now go over how do we use the SI prefixes. And these are the steps right here. So first, carry the decimal part over, and then replace the exponential part with the corresponding SI prefixes depending on what that exponent would be. And normally, we will combine the SI prefixes and the units together. So that way, there will be no spacing between the prefix and the units. For an example, let's say here we have A, where A is a value, and that is the coefficient part right there. Multiply by 10 to the third, follow a particular unit. So let's say, given an exponential notation, we have A, where A is the coefficient, times 10 to the third, followed by the unit. How do we then convert this into the SI prefix? Then first, we carry this A right here, or this decimal part over. So carry this over, and keep it the same. And now, we will be replacing the exponent. In this case right here, it is times 10 to the third. 10 to the third corresponds to the prefix kilo. And because now we're writing this out, we do not write kilo, but we write the lowercase k. And then we combine that, we put in the units, and now we combine the unit and the prefix together. So then, therefore, it become A kilo units. And depending on what the unit would be, it can be meter, it can be second, it can be any types of units. And here are some of the additional steps right here in case we deal with a more difficult example. So here are the additional steps. If we starting with a decimal number rather than a scientific notation, so sometimes we can actually convert a decimal number into and use it with the SI prefix as well. But if we starting with decimal number, then first convert that into the scientific notation first. Okay, and we know how to do that already. So if we started with a decimal number, we should be able to convert that into a scientific notation. And if we obtain an exponent that do not correspond to a known SI prefixes, then what we need to do is to adjust the scientific notation So that way, it will correspond to, so the exponent would correspond to a known SI prefix of interest. Okay, so if we end up with 10 to, for example, -5, there's no prefix for -5, so we can change -5 into a -6 by changing that scientific notation. So that way now there is a known exponent, and that will correspond to an SI prefix. Let's now try an example. So let's convert 500 and now use SI prefix for 500 meter. 5,000 meter. So in this case right here, again, we started with a decimal number, right? So what we have to do first is convert this into the scientific notation, which is then equal. So we have to move this to the left 3 times. So it becomes 5 times 10 to the 3rd meter. And now we can then see when we convert this into a scientific notation, we first carry the 5 over. So we write 5 followed by space, and now we have 10 to the third power, which then corresponds to the prefix kilo. And now we put, and the prefix kilo is written with the lowercase k. And now the unit is meter, so we combine that together, and so that equal to 5 kilometer. So we say 5 kilometer, but when we write 5 km. So pretty easy, right? Let's now try another example. Let's convert this value in and use an SI prefix to correspond with this value right here. So in this case, again, we start out with a decimal number. So we have to convert this into a scientific notation first. So in this case, we have to move the decimal to the right 3 times, which equal to 4.677. And because we are moving this to the right, we have to give it a negative exponent, right? In this case, we move it 3 times to the right, so its exponent would then be -3, followed by the unit meter. And now when we convert this into an SI prefix, then again carry this value over the entire value, equal to 4.677. And now 10 to -3, that corresponds to the prefix milli, right? So if we go back here, -3 corresponds to milli, and the abbreviation of milli is the lowercase m. So now we'll change that into the lowercase m, and followed by the unit meter, which is another m. So we combine them together and say mm. So in this case, it equal to 4.67 millimeter. And now let's try another example. 4.454 times 10 to the -7 gram. So in this case right here, let's use the SI prefix for this. And this is the case right here where the exponent that we have do not correspond to a known SI prefix. Because if you were to go back here, we can see there's no SI prefix for something with the -7. So how do we go about this? The answer, we need to change the -7 into something that is closer to it. And in fact, we can convert that into any exponent, so we can use any SI prefix that we want. But ideally, we want something that is closest to it. So in this case right here, we have -10 to -7, and the closest one to this would then be -6. So we need to change a -7 into the -6. So that way, there is an SI prefix for it. And as I mentioned earlier, we can change that to any other exponent that we want to, if we want to as well. So in this case, we have to change this to the -6. Now, when we change -7 into -6, essentially we are making it 10 times bigger, because remember, -6 is bigger than -7. And when we do that, so now that we are making the exponential part becoming bigger, we have to reduce the exponent to compensate for it, right? And in this case, because we change from -7 into -6, we have to move this decimal to the left 1 time. So therefore, this equal to 0.4454 times 10 to the -6 gram. Okay, so that is the scientific notation they correspond to. Now, some of you may be thinking, hey, this is not the correct scientific notation they get the decimal part. They're not range from 1 to 9. And if that's what you're saying, then that is a great answer. However, this is not the final answer, right? So therefore, we are okay with it because we are not listing this as the final answer. We're just changing from the -7 into the -6, so that way we can use an SI prefix to correspond to it. But this is not a final answer. And now, once we obtain this answer already, we now can change this into the prefix micro. So this is equal to 0.4454 times 10. Oh, not times 10 anymore, but now we'll be using micro. So micro is that U right there. That's the abbreviation of micro, followed by gram. Now the abbreviation of gram is G, so therefore we can now write G rather than gram. And this is what we'll be having, 0.4454 microgram. And now on this next part right here, we'll go over how to convert between the SI prefixes. And this is something that you will also need to learn. For an example, we might start out with kilometer, and we'll ask you to convert a particular value from kilometer into centimeter. And so how do we get started with this? So first, recognize which SI prefix is larger or smaller, and then find the differences that we call x in the exponents. And this can be done by taking the larger exponent and subtracting the smaller exponent. So that's how we can find this difference right here in their exponent. And then if we convert it to a smaller prefix, then we need to adjust the value by moving the decimal to the right, that x number of time. And again, x here is the difference in their exponent between the two prefixes. And if we convert it to a larger prefix, if we convert a value to give it a larger prefix, then we have to move a decimal to the left, that x number of time. And this is basically very much conceptually similar to what we have seen with scientific notation earlier. When we change a smaller prefix into a larger prefix, then essentially we're going from a smaller exponent to a larger exponent. So therefore we have to reduce the value itself by moving a decimal to the left, so that way we can compensate for it. Okay, let's now try a few examples. So in this case right here, we have to convert 0.5 kilometer into centimeter. So how do we do this? So first, recognize the differences in the exponent. Kilometer is basically 10 to the third, or kilo is 10 to the third. And now centimeter here, so C here is for centi, and the unit in meter. So in this case right here, centi is then 10 to the -2. So when we take the bigger minus the smaller, or the difference in the exponent, in this case right here, is 3 minus -2 equal to 5. So that is the differences in exponent. So x equal to 5. And so now we are converting to a small exponent, right? Because we have to convert from kilo to centi. So we converting from a larger exponent into a smaller exponent prefix. So in this case right here, we have to now move the decimal to the right, to the right 5 times. Okay, so in this case right here, starting with 5, we have to move this to the right, the decimal to the right 5 times. 1, 2, 3, 4, 5. And now we have to add 4 0 in. So that's what that value would be. And now the unit centimeter. So there you go. That's how we would do it. And now let's try another example to make sure you know perfectly well how to do this. So let's convert microgram into kilogram. Okay, and this is the value right here. So again, in this case right here, first take notice of the differences between the exponent. So in this case right here, so we have a micro is 10 to the -6, and kilo is 10 to the third. When we take the larger prefix, subtract the smaller prefix, so 3 minus -6 equal to 9. So 9 is that x right there, the differences in the exponent. So it is 9 times. And then we converted from something that is smaller to something that is bigger. So again, going from smaller to bigger. And so therefore we have to now reduce the exponent, right? Because if we want our exponent or our prefix to be larger, we now have to reduce this decimal part right here, or the value itself. And we have to now move the decimal to the left 9 times. So therefore this becomes the following. So 455.343, we have to move this to the left 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. And now we have to add in this must 0, 0 right here in between. So the final answer then equal to 0.0000000. So this 60 in there, and then 455.343. And now the unit will then be kilogram. So when we convert this much microgram into kilogram, the value itself would become the following. So not too difficult, I show how. And below are some of the practice problems for you to get used to learning how to convert between the SI prefixes. And again, please do this, and by completing all of this and showing the answer to all of this problem, and submit this along with your notes.